Hello everyone, Mr. Hein here. And today we're going to be doing something a little bit new, and that is solving systems of equations. Now, fancy words, but what that means is systems just means more than one. So the idea here is we're going to solve for problems when there's more than one equation going on. Okay? And we're going to do it through this example here, and this should help you with your work today and possibly even tomorrow. So, example here, Mr. Hein, myself, and Mr. Dean, another teacher, okay, we plant avocado trees. Mr. Hein's avocado tree was planted when it was already 3 feet tall. I'm going to do some highlighting. When it was already 3 feet tall and grows 1 foot every year. Mr. Dean's tree, on the other hand, I'm going to underline these, was planted from seed, but it grows 2 feet every year. And that's because he has better soil, humidity, and waters it more consistently. You know, you should try gardening sometimes. It's very peaceful. It's fun to garden. Everyone has to learn it, and maybe now would be the time for you to try it. But anyway, side note, the question here is when will their trees be the same height? Okay. Now there's two ways we can solve this. Is the first method we're going to do is with a table. Okay. And how would this look? So it actually wouldn't be one table, it would be two tables because there's more than one thing going on here. So I might make my first table where it's going to be years, and we'll call this the height of Hein's tree. Okay, so this is what this table will look like. And we'll go from 0 up to 5. No particular reason why, I'm just doing those numbers and hopefully something will happen. And down below, we'll do years and do the height of Dean's tree. Which we can just match that table above and go 0 to 5. Okay. Now let's piece this together and I highlight some of the information. Mr. Hein's tree was planted when it was already 3 feet tall. So that means year 0, it was 3 feet tall. And it grows 1 foot every year, meaning every 1 year, it's going to grow 1 foot. So then it'll be 4. And then it grows 1 foot another year, and then it'd be 5, 6, 7, and 8 feet. Now, Dean's tree, on the other hand, was planted from seed. So if you're planted from seed, is there a height? No. And so we're going to give that a height of 0. But it grows 2 feet every year. So every 1 year, it's growing 2 feet. That'd be at 2. Every 1 year, from 1 to 2, it's going to grow another 2 feet. It'd be at 4. Continue on to 6, 8, and 10. Now, when will their trees be the same? Now, if we analyze our tables, we can say, okay, at 0, well, Heinz was taller at 3 compared to 0. Year 1, it's still taller, 4 compared to 2. At 2, 5 compared to 4, still taller. But at 3, notice, at 3, they match up perfectly. And there is your answer. So at year 3, both trees will be 6 feet tall. And that's how you can solve this problem with a table. Okay. Now, another method you're going to be doing on these is a second method is using a graph and understanding what that looks like. So if we made a sketch of this graph, let's just draw an XY axis like so. And we'll label it years, so you can see this, and height. Now we have to use the table from above. So notice that first table, at 0, it was 3. So 0 is at 1, 2, 3. At year 1, so 0, 1, 2, 3, 4, 5. At year 1, it was at 4, and then it was at 5, and then it was at 6, then 7, and then 8. If I label these to help you see that, that's fine. And we should probably add that this is in feet, so we have units. So this right here is Hein's tree. It's Hein's tree. And it's growing 1 foot every year. You can see that from its slope. And Dean's tree, it starts at 0, and it goes to 2, so it goes up 2 feet every 1 year. And it goes up 2 over 1. Now it's at 3, 6, so you can plot the point 3 up 6. Then it's at 4, 8, so you can go right 4 up 8. And 5, 10, which would be up here. And if we connect that carefully, this tree would look like that. And there's Dean's tree. Well, notice those two lines. They end up crossing and hitting each other right there. They intersect. Now, what point do they intersect at? If you notice, that's the point 3, 6. And what's 3, 6 here? Well, 3 is the x, which is your years. So you're saying year 3, and 6 is the y, which is the height. Well, they're both have a height of 6 feet. And notice that's the same thing we got from the table, right? The idea of when things cross is when they'll be the same. Now, there's a third method, and the third method would be with equations, but that's more so what we're going to cover next quarter. If you wanted to give that a try, you know what the answer is. You can give it a go, show your teacher. If that's me, great. If that's another teacher, that's great. You can show it that way. There it is. That's how you do this. Read the problem, make a table and graph, look for when they cross. Good luck on this assignment. Ask your teacher for help if you need it.